Hey, this is Arnav, and welcome back to the roadmap for career in Android development. And this, by the way, is the second part of the video where we are going to be covering how entry level Android engineers can scale up to become senior Android engineers and Android leads or Android architects. If you are a beginner and just starting off with Android development, then you should watch the first part of the video. Link to that is down there in the description. Just go and watch that where we talk about how you can get started as a beginner and become an entry level Android engineer. Okay, let's get started. Okay, so now that you are, qualified as an Android engineer, how do you scale up from here? What are the things that you need to learn to become like a senior Android engineer? And what are the kind of requirements that a professional place would have from Android team leads? Okay, so let's talk about those things. So again, some conceptual things that you need to learn at this stage is you have to go deep into multi-threading once you start working on any desktop apps that you're making, or where the backend apps you're making or mobile apps you're making everywhere. uh, like one of the very important components that make a bridge between like entry level junior engineers to a senior engineer is the concept of multi-threading, concurrency, parallelism. Because as the tasks start getting more complex, you obviously have to parallelize your things. And in terms of Android, it's obviously like a little bit more complicated by the fact that there is one thread which is responsible for drawing the UI of the screen, and you can't do a lot of things there. Okay, there is also restrictions on what are the things that you can do on the main thread. You can't do network actions on the main thread. The app will crash if you do that. Android is not allowed doing that. Okay, understanding that what kind of tasks do take more time, like reading, writing data from the disk, reading, writing data from the network. These kind of things can take more time. How do we put them into a background thread? Also, it's important to understand is that the user needs responsiveness. They don't want to feel like the app has paused or stopped or something like that. So keeping all of these things in mind, you have to understand how to do multi-threading, how to create a pool of threads in which some of your computation heavy tasks can be run. And once those tasks are done, how do you show the result back into your UI? Okay, so these are the kind of concepts that are very important to learn. And then you have to go a little deeper into the language specific stuff, like for Java, Kotlin specific things, like understand why we need synchronized methods. So synchronized methods are methods whose body can be executed at a time only by a thread. Okay, understanding what volatile variables are. Volatile variables, are variables whose data could have been changed by a different thread. So again, I'm not getting very deep into these concepts right now in this video, but these are things that you need to understand: how race conditions happen, how synchronized, volatile, why they are used, where they are used. Okay, then you need to understand a little bit about object-oriented design patterns, which you need as your app starts getting more complex. If you're looking at an app which consists of 15-20 Java files, you don't really start seeing the need for design patterns. But when you have 100 Java files inside your project, you start seeing the need for design patterns, like where would you need a builder pattern, where would you need a factory pattern, something that you want to use only a single copy across the entire app, you can create a singleton for that. So understanding those are definitely very important. Okay, then there are the higher level patterns. So the OOP patterns are how you write code, but then there are the higher level patterns. What is a clean architecture? So doing domain driven development, where you keep your business logic in the domain does not depend on anything, and then you have data sources which handle the persistence layer. Then you have got the basically the repository layer, the UI layer, the presentation layer. How do you separate all these layers and make them work together? Okay, and then as your project starts becoming complex, as you divide it into different modules, another very crucial toolkit in your bag is going to be dependency injection. So I would suggest you start off with simple dependency injection libraries like Coin, which gives you a little bit of idea about why dependency injection is needed. Because when you start using Coin, you will see that, oh, okay, I was creating this object everywhere. Now I can create a simple Coin DSL, and I can just pick that object up from there. My code reduces. You'll visualize why dependency injection is kind of useful. Later on, you should, obviously get well versed with the most common dependency injection framework that is used across the Java world and of course across the Android world as well, which is Dagger. Okay, and along with Dagger today, there is another library called Hilt, which used along with Dagger makes dependency injection very easy to do on Android. And most big companies with big projects, they are going to be using Dagger. So knowing Dagger is going to be kind of imperative for senior Android engineering roles in those kind of places. Okay. And finally, reactive programming is also something you should take a look at. So a lot of times what happens is that how the data is updated and what to be done when the data is updated, these two pieces of the logic are sometimes written in very different places, and you don't want to kind of couple them together. So you write the code which updates the data at some place else, and you write the code of what is to be done when the code is updated, the data is updated at some place else, and then you connect them two with either a stream, a reactive stream, or an event listener or something like that. So there are frameworks around how to do these kind of things, which is the RX framework, which is the reactive programming framework. So for Android specific, there is RX Java and RX Android. By the way, when you're doing Kotlin development, you use RX Java. The name of the library is RX Java only, right? So RX is a way to do reactive programming in Android. There are patterns in Kotlin also specifically that are coming out in like these days. We'll discuss about this. But having knowledge of RX is definitely very important for senior Android roles. Android specific concepts that you also need to add to your arsenal to kind of get to a place where you can say that, okay, I know enough about Android. I have done my things so that I can be given the responsibility for a small app for the features of a big app, right? So runtime permission management. These days you can ask for permission for location. You can ask it only when the app is open or when the app is not open at that time as well. A lot of times when there could be different features in your app, and those features might need permissions that are asked at the runtime to the user while that feature is supposed to be used, rather than taking all the permissions in the beginning. How that works, okay? How background tasks work. So your apps, like say Gmail app, is synchronizing your email and downloading your email and there's attachments in the background at different times of the day. So using Work Manager and Alarm Manager to schedule tasks in your app to happen at different periods and execute them in the background even when that app is not open, or even when the phone screen is off and it is just lying on somebody's desk. How to do those kind of things. So knowing those things are important. Dealing with the operating system level providers of Android, like how to fetch users contact details, read SMSs, storage access, these kind of things. So these are all OS level providers. How to use them, that's also something that you need to know. If you deal with multimedia apps, then getting well versed with Exoplayer, which is a third party library created by Google themselves, but it's not part of Android's core operating system code, which helps you manually fine tune how videos and audio work, buffering them, coding, decoding them, setting the stream speeds, setting the codecs, play live streaming video from a certain RTMP URL on the net, these kind of things. So that's in the multimedia domain of stuff. Okay. Then another vertical that if you work with hyperlocal apps like delivery apps, etc., e-com apps, you get an idea of working is like the GPS framework, collecting location data of the device, and the Google locations and Google Maps, SDKs, so that you can embed maps, show the user's current location in the map, how to do these kind of things. Again, that's very important. Then another vertical, which is if your app works with maybe gestures or movement, or it's a game kind of an app, those kind of apps need understanding of the Android sensor framework. So there is like the light sensor, the accelerometer, the gravitometer, step sensor for how many steps the person has taken if you're making a healthcare kind of related app, and the gesture detection framework like swipe gestures, double tap, and shake, tilt, these kind of gestures. How to detect those kind of gestures, working on those kind of things is also a very nice thing to have in your toolkit. Okay. And finally, connecting with some of these services that Google has made, like Firebase for analytics, for crash reporting, for push notifications, for doing simple machine learning stuff like detecting objects and all. There is MLKit by Firebase. So understanding all of these things are like at a senior Android level, we'll be expecting that you'd be knowing these kind of things as well. Okay. So once you've done this, once you've come to this point, so congratulations, you are capable enough to be sitting for interviews for a senior Android engineer role. The fundamentals that we discussed for a basic Android engineer, those are obviously going to be asked, but some of these things like your experience with working on these Android components that we just discussed, those are also starting to be important when you're looking at a senior Android engineering role. Okay. Now that we've understood till here, what is it that you need to push you to that final level where you could be like a Android architect or Android team lead? Okay, let's talk about those things. Okay, so here comes obviously where at a team level you're not just writing code, but you're setting up culture for the team. You're setting up the way the team works. You're setting up the workflow for the entire team as well. And for that, obviously, you are the one who's responsible for designing and developing testing architecture, how tests are written for your project, how would you automate those tests, so every time somebody makes a pull request to the GitHub repository, the tests are automatically going to be running, which tests should run on which kind of pull request, designing those things, automating the release workflow as well, so that making an Android app release should not be a very manual task as your teams start growing, like the kind of teams which need an Android architect or a lead kind of position to handle the Android team. They would also be needing like automation in how the app is released. They would need weekly release cadence so that every week releases happen. So you should have a setup in place so that you can record UI tests, work with the QA team, record UI tests so that they can be automated. Use frameworks like Mockito or Mocha, which can mock out certain parts of the app which while testing are needed. So for example, you want to mock some fake data coming from the API while the tests are running, because real data, you can't run tests on real data because the real data keeps changing. So you can't, so for example, taking an example of Twitter app, right? So if you test with real data, every time you open the app, a different tweet is there at the top because somebody else has tweeted something new by that time. But when you're testing, you would probably want a consistent response. So you can test that, every time I open with this set of response, this is the tweet at the top and I can see it. Okay. So mocking things out in that sense is essential. So all of these, CI/CD testing, mocking, and QA automation. That's a whole bucket of things that are very important, and for most senior Android engineering and beyond kind of roles, like where you're getting on board to be a lead or an architect, there's going to be a lot of interview questions around this, like what are your opinions on this? In a previous place you worked, what kind of automation systems that you had set up? What are your opinions on what will you set up here? If you join us, those questions will be coming, right? Then managing large Android projects become a very defining feature for somebody who wants to be grow more further in the Android vertical and then become an Android architect. Is that bigger projects also have bigger teams. So when you have bigger teams, you want to divide the code base in such a way that people's work don't conflict with each other. And to do that, you would be creating separate Gradle modules. At Zomato, we had I think 60 plus Gradle modules. At Target, we have 300 plus Gradle modules, right? I think so. How do you work with code bases which have so many Gradle modules? How do they come together and build? Uber is the famous example of having I think more than 1,500 modules in their project, right? Then when your build system becomes so complex, so writing custom Gradle scripts so that during the app getting built, there could be some other operations that are happening. There could be analytics of the build itself. So if somebody's build fails, it triggers an alert automatically around that. Okay, pulling in different maybe security keys which are needed to build, those kind of things you have to write down in a build script. So understanding how Gradle works and understanding how alternatives to Gradle like Buck, which is made by Facebook, and Bazel, which is made by Google as separate as alternative to Gradle, which are getting used by some apps these days, because Gradle builds in very big projects can take up to 20-25 minutes time, fresh clean build, right? Build systems like Buck and Bazel have been designed to reduce that build time, make the developer experience better. So a little bit of exploring in those domains would be helpful if you're aspiring to get to that point, right? Creating custom views. So as your app grows and your design team grows, they will be coming up with very bespoke looking UI components which are very different from what you can achieve with the material design toolkit or what is default available on Android. So how do you make custom, say for example at Zomato, we had a loader which looked like a slice of pizza. At Target, the Target's logo is circular, so we use that as a loader. How to design custom loaders like that? both like in terms of implementing the somebody has designed it in After Effects. How do you write that down in Kotlin code, drawing things on the screen pixel by pixel to make those kind of loaders? How do you make custom view kind of components? How do you make a circular view or a star-shaped view? These kind of things, start getting important to know these things. Okay. Then with big apps, what happens is you have to develop some base set of rules that run in every activity, in every recycler view, so that your team does not have to do more and more boilerplate work, right? So every time a new fragment is opened, maybe some analytics data is supposed to be sent to your analytics server. So you would create a base fragment in which you would keep the analytics code, and everybody who is creating a fragment would be extending from the base fragment. Okay. Developing such common patterns inside your app's code base is again something which is going to be expected from you at this point. So writing custom base activities, base recycler views, base fragment that the rest of your team would be using. It starts becoming a little platform level work. It's called platform work because you are developing components that are going to be used by other developers to build features. Okay. Right. And mostly in big teams, your Android leads and architects, they are generally the ones who are leading the platform team. They don't directly work on features. They work on the components that are needed by the rest of the team to make their life easier, right? Performance optimization, using Android Profiler, detecting memory leaks, using leak canary. You should be the guy who should be always looking for ways to make your app smaller, faster, leaner, meaner, all of that stuff. You should be at the forefront of doing those things. As a senior Android engineer, if you develop the attitude as well as the skills to be able to, make your app free of memory leaks, crashes, tune it for faster performance. There are a lot of things like this async layout inflator. So inflating the layout can become a time-taking process if the layout is complex. So there's an asynchronous layout inflator as well, which you could be using. These kind of things start becoming, more and more important. Okay. So, and then finally, you should also be somebody who has a finger on the pulse of the Android ecosystem. Stay in touch with all the latest and greatest stuff that is happening, right? Watch Google I/O, see the direction in which the makers of the Android SDK and the Android OS team, what new things that they are thinking for the next version of Android, right? Stay in touch with those things, new libraries that are coming in an alpha level, beta level, trying those out and seeing if they can be useful for your team to use eventually. Those things start becoming very important. So today, speaking, it's in 2021, I think some of the latest and greatest today is a lot of people are starting to build UI using Jetpack Compose instead of using XML. So take a look at that, how that is working, right? And evaluate the pros and cons, whether in your team using Jetpack Compose would be a good idea or not. These days in Kotlin, there are a lot of new experimental features like flows, streams, and coroutines, which together can give you an alternative to RxJava. And a lot of apps are starting to move towards that because the syntax is much more easier to see. So how can you develop an alternative to RxJava using coroutines and flows? Something like that. Maybe you can read about that. Dynamic delivery. So you can, deliver smaller features of your app later on after the app has been downloaded. So the app size becomes small and people download the app, they can use the basic features. If they try to use a certain other feature, then the separate component of the app will get downloaded. So this is something I was doing at Zomato before I left and I could not actually complete. Was Zomato's chat module is actually written in React Native, so that kind of is it makes the app size of the app 4 or 5 MB more. We could reduce the size of the app by 4 or 5 MB if we remove that. And not everybody is chatting. Like when they download the Zomato app, the first thing that they want to do is order. Like if their order does not go through, they might want to chat. At that point, we can download the chat component into the app and do it. So we can use something like dynamic delivery and feature modules to achieve that. And understanding how these things work, again, would be something that would be your responsibility if you are the Android lead or the architect, right? Like we discussed, custom views, similarly custom animations as well, using motion layout. Again, latest and greatest stuff. You should cover things like that. Once you've done all of that, so congratulations, you are at the point where you should be looking at within your own team, become somebody who leads initiatives, right? Or when you're looking at openings and there is an Android architect or a lead Android engineer or a principal Android engineer kind of openings, and you are at this point, you have garnered all the experience that I've talked about till now, you can start applying to those kind of positions at this point. Okay. So I hope this was helpful, both the first part and the second part of these videos, and I really hope that people who are starting off in their journey as Android developers, these videos give them an idea of what are the things that they need to know for various levels of Android engineers that the industry is looking for. By the way, to become like a senior or lead Android engineer, there's a lot of system design and low level design, builder patterns, and design patterns, object oriented. These kind of things you need to cover. And what better place to cover these things than attend a Scalar masterclass? So visit scalar.com. Just scroll to the bottom. There is you will find a link to the masterclasses, and we have masterclasses every week, every few weeks, and most of these masterclasses deal with system design, design patterns, the exact set of things that you need as an engineer, whether it's mobile developer or whether as a general engineer, you need to understand these kind of things as you want to grow. So go ahead to scalar.com, register for the next masterclass that is coming up, and brush up your concepts on system design. Along with that, definitely like, share, and subscribe this video if this was helpful. We would be coming up with more such roadmaps in the next few days.